Now we've got a probability question which uses a probability tree. So it says whenever Lois and Denver play a game of bubble on their computer, the probability that Lois wins is 0.3. No game of bubble ever ends in a draw. Sounds like fun. Now it says complete the following tree diagram to show the probability of what can happen when Lois and Denver play 2 games of bubble. So we know that the probability that Lois wins is 0.3. So Lois wins is 0.3, and we know that Lois wins there 0.3, and Lois wins there 0.3. Now we should know from our probabilities that our probabilities will add up to 1, and 1 being certain. So if we've got 0.3, then we know that 1 minus the 0.3 will give us the probability of Denver winning. So 0.3 taken away from 1 is 0.7, and so Denver winning in each of those is going to be 0.7. Now what I like to do with these questions is in this part at the end, I'd like to just write my final probability of my outcomes. So the first one is Lois winning and Lois winning. So that is 2 W's for Lois, or in this case, because we've got a Lois and Denver playing, we might decide to use 2 L's. And so to work that out, because we want Lois winning and Lois winning, we know that in probability and means multiply. If we wanted to use an or statement, that would be a plus. So we want Lois winning and Lois winning, so that's 0.3 times 0.3, which is 0.09, not to be mistaken with 0.9. Lois and Denver winning, so let's call that L and D. So 0.3 times 0.7, 7 threes are 21, so 0.21. Lois and Denver, 0.7 times 0.3, so let's call that DL, so that gives us actually the same probability. And then Denver winning and Denver winning, 0.7 times 0.7 is 7 sevens are 49. Now to double check, we might just want to add up our probabilities to make sure that they add up to 100. So 0.49 and 0.21, well, and the 1 will take us to 0.5, and the 2 in the tenths column will take us up to 0.7. Another 0.21 will be 0.91, and the 0.09 takes us out to 1. So we know that we've done that correctly. Now for the last part is where they usually ask us to use our probability tree to answer a question. And what they asked here is what's the probability that Denver wins both games. So the only one that we're interested in is if we want Denver winning both games is Denver wins and Denver wins. So it's this probability at the bottom, and we've already worked it out. If we like to, we can show our workings again. So the probability of Denver winning both of our games is going to be our 0.7 times our 0.7, which we've done above, which gave us our 0.49.